Okay, so welcome to section 12.5. We are going to be talking today about polar coordinates. Okay, so polar coordinates are a new way of plotting a point. It's a way of thinking about a point, x, y, differently. Okay, and we did that. We've already started to look at how to plot points on the axes differently. Last time we talked about the parameter, and we made x a function of the parameter and y a function of the parameter. And maybe the best way of thinking about that was when we used the letter t and the parameter was t. I said you could think of t as time passing by, and that x would change based on time and y would change based on time. And so you could plot your point xy and it would change when t changed because the point was like moving through space as time changed. Okay, so that was last time. This time we're going to learn a new way of plotting the point, and this is with a polar coordinate. Okay, so let's suppose that I'm going to be at the spot 3, 5, which is right here. So this is my coordinate point 3, 5. And we all know that you can get that by going right 3 units and up 5 units. And that will get me to the spot 3, 5. I'm going to change this 5 to a 4. You'll see why. Up 4 units. Okay, instead of doing it that way, instead, in blue here, I'm going to talk about a different way of getting that. I'm going to say start at the origin and add an angle of a certain amount, which I should note, hold on. Okay, add an angle of 0.93 radians, which is about 53 degrees. So add an angle of about 53 degrees, which is 0.9 radians. So then I want you to go out along that length a distance of 5. A distance of 5. And if you do that, you will get to the same exact location that you got to when you did 3, 4. When you went right 3 and up 4. And I know that because I know right triangle trigonometry. If you have a point and you got to that point from the origin by going right x and up y, so you got to the space x comma y, then there's a certain angle that was in this right triangle, and at that angle you went out a distance of r. And what will have to be true is that x squared plus y squared is r squared, and additionally the tangent of theta is y over x, where that theta is that angle. And that's what I did really quickly. I looked up what the inverse tangent of 4/3 was so I could know how many degrees I needed to tell you to rotate. If you went that many degrees, you would get along the right axis. Okay, now, just to keep in mind, there are a few different ways of doing this. You can get to the same location of 3, 4 in a couple of different ways. So this 3, 4 in polar coordinates, the polar coordinates of that are 0.9 radians, and r goes first. So you do this in terms of, you say r comma theta, and that's going to be 5 comma 0.9 radians, because we'll be in radians for this. So there's another way of doing that. Let's do a new point, though. This 0.9 radians is not very intuitive, so I'm going to do a new point. Let's do the polar coordinate. Let's do 1 comma pi thirds. So that's 60 degrees and then out 1. So when you do this, here's my xy axis. I'm going to rotate 60 degrees, and then I'm going to go out a distance of 1. And that's going to get me this point right here. And there are different ways in which I could have gotten that point, because I could have said, instead of going pi thirds and then going out 1, instead go out 1 from 7, 7 pi thirds. So 7 pi thirds is pi thirds plus 2 pi. So that's just around 1 more time. And so it's the same exact point because it's the same exact angle, or it's a coterminal angle. So that was one way. Another way is you could have said to go out 1 and go negative 5 pi thirds. And so instead of going clockwise, instead of going counterclockwise, we went clockwise. And then there's one other way of doing this, okay? We can have negative radii. We can have negative radii. And what a negative radius does is it tells you to go, instead of along the positive angle, it tells you to reverse that much along the angle. So for example, what if we had, let's say pi 6 as our angle, should go in the second spot, negative 2 comma pi 6. So pi 6 is 30 degrees, so we're going to go to 30 degrees. But instead of starting at the origin and going in the direction of 30 degrees, we're going to go in the opposite direction of 30 degrees, 2 units, 1, 2. And so this is the point I'm talking about now. And this is the same as 2 comma, well, this will still be 30 degrees because these angles from here to here are vertical angles, and so that's still 30 degrees, which would be 7 pi 6. So these are the same points as well. Okay. And the relationships that we have discovered, I haven't talked about these ones on the left here, but because this is we're making right triangles, the Pythagorean theorem holds. And so this is all based off of this triangle I drew in the beginning. An angle of theta, a distance out at r, gets me to the point right x up y. And it will work in any direction. And so here's my Pythagorean theorem. Here's my tangent of theta is opposite over adjacent. And then the other thing that we'll notice is that if I did the sine of theta, I would have gotten y divided by r. But what we do is we multiply both sides by r. And same thing for cosine. These 4 formulas you need to have memorized. They're really important formulas. And you'll see that as we work through some example problems. Okay, so in this first set of example problems, I'm going to convert between polar. So I have a polar coordinate, and I'm going to make that into an xy coordinate. All right, and so I'm just going to graph this one and show you how easy it is. So this says to do a radius of negative 2 at an angle of 3 pi halves. So if we're going back to trig here. Here's my angle 3 pi halves. I'm going in this negative y axis, but I want to go backwards too. That would put me right here on the positive part of the y-axis. And so we know this point. This is the point 0, 2 when you're talking about rectangular, which are x, y. Here's another way you can derive that. It's fine to just plot it and know that's the point 0, 2. That's perfect full credit. But also realize that x is equal to r cosine of theta. And so x equals negative 2 cosine of 3 pi halves. But the cosine of 3 pi halves is 0, and so this is the coordinate x coordinate 0. Likewise, y is r sine theta. And so if I replace r with negative 2 and theta with 3 pi halves, the sine of 3 pi halves is negative 1. So I get negative 2 times negative 1, or positive 2. And so that's the point 0, 2, just like I knew it should be. Okay, so let's look at the second point here. I want you to, on the second point, take these 2 formulas, x equals r cosine theta and y equals r sine theta, and tell me what this coordinate is in terms of rectangular coordinates. So x comma y. You're going to use those 2 formulas to do it. Because 3 pi halves is, or 3 pi fourths is along here like this. And so it's not an easy one to just look at and see. Okay, so that's for you to do on your own. Now in this next one, we're going to reverse and go backwards. Now you have a rectangular x comma y. So rectangular is x comma y, and I want you to tell me the polar r comma theta. Okay, this first one again is one that you can do just by plotting. X equals 3, y equals 0. And so you know what that point is. That point is a radius of 3 out from the origin at an angle of 0 degrees, which is the same. And then also, you could have said 2 pi, 3 2 pi. Or you could have said negative 3 pi. So those are all perfectly acceptable answers for what this coordinate is in polar form. Okay, so let me show you another way of doing it. We can use these formulas from above. What you can do is use the ones on the right now. R squared equals x squared plus y squared. And my x coordinate was 0. My y coordinate, no, wrong way. My x coordinate was 3. My y coordinate was 0. So this gives me r squared equals 9. So r is plus or minus 3 based on what angle you choose. Then the other thing that the formula you're going to use is tangent of theta equals y over x. So this means tangent of theta equals 0 divided by 3, or tangent of theta is 0. So I can get theta by doing the inverse tangent of 0, and that is 0. And so now you know, or by the way, you could have gotten some other answers. There are lots of thetas for which the tangent is 0. You could have done pi also. If you chose pi, though, you needed to choose r as negative 3 because that's along the wrong axis. Okay, so here's a second number. I'm going to go ahead and do this one with you. So remember, this is the rectangular. We're given x, y. If you look at this, it's not an easy one to do. X equals radical 3, y equals 1. So what is that point in polar coordinates? Well, let's find r. R squared is x squared plus y squared. So r squared is 3 plus 1. So that means r squared is 4, and r is plus or minus 2. For the angle, the tangent of theta is y over x. So that's 1 over radical 3. This means, what's the angle where the tangent is 1 over radical 3? Let's think about that. 1, 2, radical 3. So opposite is 1, adjacent is radical 3. That's pi 6. Okay, so pi 6 is in the first quadrant. The point I want is in the first quadrant, so that's the one I choose. So my answer is going to be positive 2 pi 6. Now, if I wanted an answer, if my angle were in the, or if my point were in the third quadrant, then I would choose pi 6 as the reference angle, but in the third quadrant. So like that would be 7 pi 6. And you can even use 7 pi 6 in your answer. Just make sure you use negative 2 as the radius so you go back up into the first quadrant rather than the third quadrant. Okay, and so 2 pi 6, or this is also a fine answer, is that rectangular coordinate in polar form. And so all we're doing, just to review, all we're doing is we're taking a point right here, and we're thinking of multiple ways of representing that location. Multiple ways of representing that location. Okay, so moving on, now we're going to work on this not just with points, but with equations, with expressions involving x and y and an equal sign. And so this says convert the rectangular equation to polar form. And in order to do this, we're going to have some sort of r's and thetas. So we'll have functions of r equals functions of theta. Usually r is just a function of theta. Okay, so in order to do this, we're going to use these formulas back here, and we're going to replace any x we see with r cosine theta and any y with r sine theta. So here's an x, that's r cosine theta. And then the y is going to be r sine theta. there you go, you're done. I'm going to go ahead and solve this for r, just because it's a little ugly right now, but you don't have to. So I'm going to add 2 to the other side. I'm going to factor out r. This is not necessarily much prettier. So r is 2 over 3 cosine theta plus 5 sine theta. And in the next section, we're going to learn how to graph these. Very exciting. Okay, next example says to go the other way. So now, instead of having a function involving x and y, I have a polar function involving r's and thetas. And so I need to replace this with x's and y's. Okay, so in order to do that, remember that x is r sine theta, y is r, x is r cosine theta, y is r sine theta, x squared plus y squared is r squared, and y over x is the tangent of theta. And so you're going to be using these 4 formulas. I already see that I have an r squared. I think I will eventually make that x squared plus y squared. But before I do that, I'm going to look at the sine theta and cosine theta. Now, I guess I could, see, the problem is I need an r to make those x and y. So I'm going to put an r in there. I'm going to multiply both sides by r. And then I'll have r sine theta here. But I need another one for the cosine to get the x. So I'm going to have to multiply by r twice. This r in green, I multiplied to get r sine theta. That's y. This r in blue, I multiplied to get r cosine theta, which is x. And so now what I have left, I have yx on the right, but now I have 4 r's on the left, or r squared times r squared. Let's put it that way. And now let's use this last Pythagorean identity here and replace those with x squared plus y squared, each one of them. And there is not going to be a nice way to rewrite this other than x squared plus y squared, quantity squared, is xy. And we can just end there. But notice I don't have a polar equation anymore. I have y's and x's. Okay. Now let's do a little bit of calculus here. So we still are interested in slope. We're always going to be interested in slope. This is the slope of the tangent line, because we still have tangent lines, and we would like to know the slope of that, even though I don't see y's and x's. Slope is always going to be dy dx. Okay. This time, remember when we had parametrics, we just found dy dt and dx dt and divided. It's a little bit more difficult this time because I'm going to do some side work here. Y is r sine theta. And so when I find dy d theta, I have to use the product rule here because I have r who has a derivative. His derivative is dr d theta. And I have sine of theta who has a derivative. And so I have to use the product rule here. So the derivative of r is dr d theta times sine. Now I'm going to do r times the derivative of sine, which is cosine. And so this is dy d theta. Remember, x was r cosine theta. So when I find dx d theta, that is going to be the derivative of r times cosine plus r times the derivative of cosine, which is negative sine. And now I'm going to plug those into this formula over here. So it should be the derivative of y. This dr d theta, I'm going to just simplify that to an r prime. So it's r prime sine theta plus r cosine theta divided by r prime cosine theta minus r sine theta. And that's the formula for dy dx. All right, in our last example here, we're going to go ahead and talk about tangent lines. For a horizontal tangent line, this happens when dy d No, when dy d theta equals 0, when your slope is 0. So that's going to happen when the numerator, this r prime sine theta plus r cosine theta, is 0. So this is when we have a horizontal tangent line. Notice I gave you that r is 1 minus 2 cosine of theta. So we can do the derivative of that. R prime would be 0 minus 2 times negative sine of theta. So it's just 2 sine theta. R prime is 2 sine theta. So my horizontal tangent line is going to be when 2 sine theta times sine theta plus r, which is 1 minus 2 cosine theta, times cosine theta is 0. All right, so let's clean this up and try to solve for theta. This is not all that easy to do. We've solved these before, but when we solved them, it was back in pre-cal. This is a quadratic in cosine of theta, and I'm going to go ahead and solve this for you. Remember, sine squared plus cosine squared is 1. So I'm going to solve for this sine squared. With this sine squared, I'm going to replace it with 1 minus cosine squared theta. So I have all cosine thetas. That's much better. Okay, so now if I distribute this 2 and collect like terms, I have 2 minus 4 cosine squared of thetas plus a cosine of theta equals 0. Be careful there. I collected like terms and distributed at once. And now I'm going to make this 4 positive. So I'm going to add everything to the left, to the right side. Minus 2. So I moved it all over to the right. Okay. And now the way we did these is we did a substitution. So I'm going to let W equal cosine of theta. And so we have 4W squared minus W minus 2 equals 0. And this does not factor. So we're going to complete this, or we're going to use the quadratic formula. Use the quadratic formula. So W equals negative B plus or minus the square root of B squared minus 4AC. So that'll be plus 8. Sorry, I'm getting ahead of myself. All over 2A. I guess this did factor. So that's going to be 1 plus or minus the square root of 9. So that's 3 over 8. So 1 plus 3 over 8 is 4 over 8, which is a half. And 1 minus 3 over 8 is negative 2 over 8, so negative a fourth. So that did factor. Okay, so we get W equals a half and negative a fourth, but we haven't solved for theta yet because cosine of theta is W, so cosine of theta is a half, or cosine of theta is negative a fourth. And now we solve this for theta. So when does cosine of theta equal a half? That's at 60 degrees. In quadrants 1 or in quadrant 4. But let's just solve it for the first one. I think that should be fine. All right, and then when does cosine of theta equal negative 1/4? Well, we would have to do, we would have to use our calculators on that one. Okay, and I'm going to leave that to a calculator question. This is where we have horizontal tangent lines. Vertical tangent lines are when dx d theta, which is the denominator of the derivative, equals 0. So what I want you to do for homework, you don't have to solve all the way for theta, but I additionally want you to find dx d theta. You're going to have to use this formula here and use it for your r and your r prime. Just plug in and collect like terms, and then we'll solve it later.